Hi everyone. Welcome to Go Classes. So in this session, we will solve some questions. Go Classes DBMS practice set 1 questions. Okay. So the solutions we will discuss. Did you try these questions? The practice set 1 questions. Did you try them? So in this practice set, we have some questions from the Ullman. A lot of questions from the Ullman we have taken. The DBMS book by Ullman. Okay. So those questions we have taken in this practice set. And some questions from the GATE exam, some questions from the ISRO exams. Okay. And yeah, so many standard questions we have in this practice set. Okay. In this practice set 1. Okay. So let's start the video solution. So one more thing, I will put this video, this discussion, this practice set 1 video solution I will put on the Go Classes YouTube channel. Okay. So some questions I will give you in this practice set. Okay. Those you can tell me your answer in the comments. Okay. So anyway, if anyone who is not a Go Classes student is watching this video, then for the in the Go Classes you can join our complete course for the GATE exam. Okay. Complete course for GATE 2024, complete course for GATE 2025. Okay. So those courses are available on the GATE, on the Go Classes website. You can check it out. Okay. You can just visit the Go Classes website and there you can check it out. Okay. So, and also discrete mathematics and C programming. These 2 courses are freely available for all the learners, for all students. Okay. Complete discrete mathematics and complete C programming. These 2 courses are freely available for all people. Okay. So on the Go Classes website, you can go on the Go Classes website, you can go and you can find out discrete mathematics and C programming. These 2 courses you can find out. Okay. So these complete courses are freely available. Means you will find all the video lectures, all the lecture notes, all the homework, all the quizzes. Okay. Everything. Okay. So for these 2 subjects, everything, the complete courses, the complete discrete mathematics and complete C programming, these 2 courses are freely available for all people. Okay. All you have to do, just visit the Go Classes website. Okay. So there you will find that these 2 courses are freely available. Okay. And if you want to join GATE CSE complete course, if you want to join, then you can visit Go Classes website. There you will find a page on the home page. You can visit Go Classes website. On the home page, you will find this complete course. Okay. So this complete course you can join for the best quality learning. So if you don't want to do any rote learning, okay, then basically for the best quality learning, then you can join this complete course. Okay. Also, there is a Go Classes test series, GATEOverflow test series. So for joining this test series, you can visit, for joining this test series, you can visit the GATEOverflow website. Okay. On the GATEOverflow website, you can visit and you can join this test series, this GATEOverflow plus Go Classes test series. This test series has quality questions. Okay. All the questions that are there in this test series, all these questions are based on standard questions. Okay. These questions, these are based on standard resources. Okay. So all the questions are quality questions, well-framed questions. Okay. With correct explanation, correct answer. Okay. There is no wrong explanation. There is no poor question. Okay. So, and also you can put your comment if in any question, if you have doubt in any question of the test series, if you have doubt, then you can ask your you can put your doubt in the comments. Okay. So now let's start this session. And also we have Android app. Go Classes Android app is there. So you can download this Android app and you can watch all the lectures. Basically like this discrete mathematics and C programming. These 2 courses are freely available for all the people, for all the learners. Okay. So you can join, you can download our Android app and there also you can watch. So on the Play Store, you can search Go Classes. Okay. Now let's move on. And if you want to join our Telegram channel for doubt discussion, for all your doubt discussion of GATE CSE, okay, you can join our Telegram group. So this is the Telegram group username. This is the username GATE CSE _ Go Classes. This is the username for for the Telegram group, and this is the channel name. This is our channel name, Telegram group channel. The Go Classes channel. This is the channel username. Okay, and also there is a group for the GATEOverflow. This is the group of GATEOverflow and the username is GATEOverflow _ CSE. This is the username. Okay. So you can join these groups, these channel, the Go Classes channel, the Go Classes group and GATEOverflow group. So these you can join for your doubt discussion. Any doubt related to Go classes courses also you can discuss there. Okay, if you have any doubt related to Go classes courses, if you want to join Go classes courses, and if you have any doubt, okay, related to that, that also you can ask in this group. Okay, now let's move on. Basically all these links are available in the comments. Okay, so this video, if you are watching on the YouTube, on the Go classes YouTube channel, if you are watching this video, then in the description all the links are available, like this channel link, group link, Telegram group link. Okay, all these links are available in the description, so you can check the description. Every link is available. Okay, the you can notice the complete course link is available, discrete mathematics course link is available, C programming course link is available. Okay, so all these courses link, like this Android app link, this link is available in the description. So all the links, test series link, okay, the complete course link. So basically each and every link is already available. The complete course link is also available in the description. Okay, so you can check the description. In the description you will find all the links. Okay, now let's start the session now. So most of these questions are taken from GATEOverflow website. Okay, so most of these questions are standard questions. Actually, all the questions are standard questions, but the screenshot I have taken from the GATEOverflow website. Okay, and for GATE CSE, for GATE Computer Science previous year questions, you can download the GATEOverflow book. Okay, you can download the GATEOverflow book from this website, and the link again is available in the description. Okay, so you can check out the description. In the description you will find the link of GATE CSE PYQ books. Okay, that also you will find. Okay, or you can visit the GATEOverflow website. On the GATEOverflow website you can find all the GATE Computer Science previous year questions book you can find. Okay, now let's start. Let's see the first question. Tell me the answer for this question. Did you try? This is a very easy question. This is a ISRO question 2011. The question is saying that which normal form is based on, which normal form is based on. So which normal form is based on the concept of partial dependency or full dependency. Okay, so which normal form is based on the concept of full functional dependency. So you know second normal form. Okay, 2NF. This is based on the concept of partial dependency, full dependency. Okay, so in this 2NF, what should happen? What is the definition of 2NF? Tell me, can anyone tell me what is the definition of 2NF? The definition of 2NF, if you notice, that is that in the definition of 2NF, what should happen? It should happen that every non-prime attribute, remember, every non-prime attribute, what should happen? Every non-prime attribute must be fully or partially. Every non-prime attribute, remember, every non-prime attribute must be fully dependent on every candidate, must be fully dependent on, okay, fully dependent on every candidate key, every candidate key, right? Yes or no? So remember, every non-prime attribute, must be fully dependent on, okay, fully dependent on every candidate key. Okay, must be fully dependent on every candidate key. Is this clear? So you can notice this 2NF, this 2NF is based on the definition of full dependency, partial dependency. Okay, so this is the definition of 2NF. Every non-prime attribute, okay, must be fully dependent on every candidate key. Now let's see the next question. This is ISRO 2003 question, 2013 question. Tell me the answer. Consider the following functional dependencies are given to you, and the book table is given to you in the relational database design. Okay, determine the normal form of the given relation. Determine the normal form of the given relation. Whenever you see this question, remember what you need to do. First of all, these big attribute names you can convert into small names. Okay, these big names you can convert into small names. You can say that I determines T, I determines P also, correct? I determines T, I determines P, P determines A. Okay, so this is what is given to you. So from here, what you do, you find out what are the candidate keys. The question is asking the normal form. The question is asking the normal form. So from here, you find the candidate key. What is the candidate key? So you can assume that your book table has these attributes, I, T, P, A. So these attributes. Now you can notice which attribute does not appear on the RHS of any functional dependency. Which attribute does not appear on the RHS of any non-trivial functional dependency? That is your I. So you check what is I plus. What is I plus? What is the closure of I? So the closure set of I is I, T, P, and P can determine A. Okay, so you can clearly see The only candidate key is I. This is the only candidate key. So what are the non-prime attributes? What are the non-prime attributes? So non-prime attributes are P is a non-prime attribute, A is a non-prime attribute, T is a non-prime attribute. These are non-prime attributes. Now you can clearly see that you can clearly see. First of all, look at this. Look at this. Can I say here what is happening? P is not a super key, right? Non-super key is determining non-prime attribute. Yes or no? Yes or no? Correct, correct. Yes or no? So non-super key, not super key. P is not a super key. You can notice P is not a super key. So not a super key determines non-prime attribute. This is a violation of what? This is the violation of 3NF. Yes or no? So it simply means not in 3NF, right? This simply means not in 3NF. What is the definition of 3NF? What is the definition of 3NF? The 3NF definition clearly says that a relation is in 3NF if and only if a relation is in 3NF, is in 3NF. If and only if, this is if and only if statement, if and only if no functional dependency, no non-trivial functional dependency, okay, no non-trivial functional dependency, okay, where non-super key, where non-super key determines non-prime attribute, determines non-prime attribute. Okay, so this type of functional dependency, this type of functional dependency should not be there. Is this clear? This type of functional dependency should not be there. Okay, so a relation is in 3NF, a relation is in 3NF if no non-trivial functional dependency, if there is no non-trivial functional dependency where not super key determines not a non-prime attribute. Okay, this is the definition of 3NF, right? Yes or no? Okay, there is no such non-trivial FD. There should be no such non-trivial FD. So definitely this relation is not in 3NF. So definitely not in 3NF, so not in BCNF, right? So these are definitely gone. Okay, not in 3NF, so not in BCNF automatically. Okay, because in the BCNF, what should happen? In every non-trivial functional dependency, LHS must be super key, right? So here you can notice LHS is not a super key. And so clearly this is a non-trivial functional dependency. So this is a non-trivial FD, and you can notice LHS is not a super key. So this is not in BCNF. Okay, so this is not in 3NF, this is not in BCNF. Now what about 2NF? What about 2NF? So you can clearly see if you have a single attribute candidate key, if you have single attribute candidate key, then is it possible that some non-prime attribute can be partially dependent on this? Is it possible that some non-prime attribute can be partially dependent on this candidate key? This can never be possible, right? Okay, so you can clearly see that it is never possible. It is never possible because you have a candidate key with single attribute. So it is never possible that some proper subset of candidate key can determine non-prime attribute, right? Okay, so you can clearly see that what is the violation of 2NF? What is the violation of 2NF? The violation of 2NF, what is that? The violation of 2NF happens if there exists a non-trivial FD, if there exists a non-trivial FD, if there exists a non-trivial functional dependency where proper subset of some candidate key, where proper subset of some candidate key determines some non-prime attribute, right? Okay, some non-prime attribute. This is the violation of, this is the violation of 2NF. Okay, this is the only violation of 2NF, right? This is the violation of 2NF, and this is the only violation of 2NF. This is the violation of 2NF, and this is the only violation of 2NF. So you can clearly see that if your attribute, if your candidate key is a single attribute, if your candidate key is simple, okay, it is not a composite, it is simple, it has single attribute, then proper subset does not exist. Yes or no? Proper subset of this I, proper subset of this I cannot determine non-prime attribute. Okay, so definitely I can say this is in a second normal form. Correct? Yes or no? So definitely this is in a second normal form. Okay, so this relation is in second normal form, but this is not in third normal form. Okay, the violation of third normal form is this. This is the violation of third normal form. Okay, let's move on. Let's see this question. Tell me the answer. This is another ISRO 2014 question. ISRO 2014. Consider the given table. A table is given to you. Okay, first of all, you have to find the functional dependencies, right? Yes or no? First of all, you have to find the functional dependencies. I told you in this notation how to find the functional dependency. In this notation, see, in this notation, how to find the functional dependency. In this notation, I told you that if you have some attribute, like if you have some attributes, okay, like if I give you some attributes, for example, maybe ABC, ABCD, and if I want to write this, if I want to write A determines B, then how will I write this? A determines B. I will write like this. This arrow means RHS. This arrow means RHS. Okay. So what is this notation? In this notation, this arrow means RHS, right? This arrow means RHS, correct? Okay. Arrow means RHS and not arrow, non-arrow. So arrow side means RHS and non-arrow side means LHS, right? So non-arrow, like here there is no arrow. Yes or no? A determines B. So here there is no arrow. Here there is no arrow. So non-arrow side, that is LHS, and arrow side, that is RHS. This is how you can write. And if I want to write AC determines D, how will I write? AC determines D. This is LHS, right? This is LHS, right? So AC means like this. And the arrow will come on D. The arrow will come on D. Okay, so you can put like this. You can put like this. Is this clear? Tell me, is this clear? AC determining D. Non-arrow, that is your LHS. And arrow, that means your RHS. So this is how you can put AC determining D. Like, for example, if I give you this, what this will mean? If I give you this, what this will mean? If I give you this, what this will mean? This will mean that AC determines BD. This will mean AC determines BD, correct? Okay, so if I give you this, then that will mean AC determines BD. Okay, because arrow means RHS. So AC determines BD. Okay, if I give you this, then what this will mean? Okay, from here, if I give you this, what this means? This means A determines BC. This means A determines BC. And if I give you this, then what that will mean? Okay, but yeah, okay, so you understood this, right? You understood this. Okay, so this is enough. You understood this. So finally, from here, what are the dependencies? First, you find the FDs. So what are the FDs? You can clearly see C determines D, right? Or C determines B. So you can say C determines B. This is one FD. This is done. Next, what is that? AB determines CDE. Okay, AB determines CDE, correct? AB determines CDE. So that is your another. So there are two functional dependency. Now you find the candidate key. What are the candidate key? In this, what are the candidate key? So you can notice which attribute is not on the RHS of any FD. Which attribute is not on the RHS of any FD? A is not on the RHS of any FD. So A must be present in every candidate key. A must be present in every candidate key. Now, what is the closure of A? That is only A. A is not enough. Okay, so let's see who can give company to A. So let's see AB closure. What will be AB closure? AB closure will be A, B, C, D, E. All the attributes you got. Yes or no? So definitely AB is a candidate key. So definitely I can say AB is a candidate key. AB is a candidate key. What about else? Like for example, if someone can determine B, okay, remember C can determine B, right? Yes or no? AC can determine ACB, and now AB can determine everything. Now AB can determine everything. Now AB can determine everything. So AC is also candidate key. What else is a candidate key? What else is a candidate key? So AB, AC are candidate key. What else is a candidate key? So can I take like ADE? No. Okay, nothing else is a candidate key, right? Nothing else is a candidate key. Only two candidate keys you have. So how many non-prime attributes? So what are the non-prime attributes? What are the non-prime attributes? So A, B, A, C are the candidate keys. So automatically D, E, these are the non-prime attributes. Okay, these are the non-prime attribute. Okay, now look at this. Here what is happening? Here what is happening? Here what is happening? In C determining B. Okay, here what is happening? You can clearly see not a super key, but this B is a prime attribute, right? So this I can say not BC enough, right? From this I can say not BC enough. From this I can say not BC enough. From this I can say not BC enough because not a super key, correct? Yes or no? Because this C is not a super key. This C is not a super key. Because this C is not a super key, so I can say not BC enough. So I can definitely say that BCNF will not be there. Definitely BCNF will not be there. Okay. Now anyway, let's check for 2NF. Let me check for 2NF. So what are your candidate keys? Your candidate keys are AB, AC. Okay, check for 2NF. Check 2NF. Okay, remember these are your candidate keys. These are the candidate keys. So these are your candidate keys. AB, AC, these are the candidate keys. Now let's check 2NF. From the now, okay, let's check 2NF. So first you tell me what about 2NF? Let's check it out. Let's check what is 2NF. What about 2NF? So in this 2NF, what is the method one? Checking 2NF, what is the method one? Method one is find this type of FD. Yes or no? Find this type of FD, like proper subset, where proper subset of candidate key, where proper subset of a candidate key determines non-prime attribute, where proper subset of candidate key determines non-prime attribute, non-prime attribute. Correct? Okay. So can you find this type of FD? Can you find this type of FD? So what are all the proper subset you have to check? All the proper subset you have to check. Okay, all the proper subset of candidate keys you have to check. So how many proper subsets of candidate key you have? You have these candidate keys. So how many proper subsets of candidate keys you have? So you have to check A plus, you have to check B plus, you have to check C plus, right? You have to check what A can determine, what B can determine, what C can determine. So because from this you can clearly see what are the proper subsets. What are the proper subsets? What are the proper subset of candidate key? Proper subset of candidate key. Like A is a proper subset of candidate key. B is a proper subset of candidate key. C is a proper subset of candidate key. So you find their closure. You find their closure. A closure will be A. B closure will be B. A closure will be A. B closure will be B. C closure will be CB. C closure will be CB. So can it happen that proper subset is determining non-prime attribute? Can it happen? There is no such FD. Yes or no? There is no such a functional dependency. There is no such a functional dependency. Correct? There is no such functional dependency. We don't have any such functional dependency. There is no such functional dependency. So 2NF. Yes or no? So it means this is in 2NF. So this relation is definitely in 2NF. This relation is definitely in 2NF, right? Is this clear? This is definitely in 2NF. What is the another method of checking 2NF? What is the another method of checking 2NF? That is your definition. You can apply the definition. The another method of checking 2NF, that is you can apply the definition. Okay. Tell me. AB determining, like, is this partial dependency or full dependency? Look at this dependency. Look at this dependency where candidate key determines non-prime attribute. Okay. Look at this dependency. Look at this dependency. And you check. And you check. This dependency you check. And you check is it full or partial? Yes or no? You check is it full or partial? Is it full or partial? This is what you check. So how many you will check? This is full or partial. So how many you will check? You will check with AB every non-prime attribute you will check. Correct? You will check with AB every non-prime attribute. Like with every this you will check. This is full or partial. Tell me. Can you remove something from the LHS? Can you remove something from the LHS and still determine D? Can you remove something from the LHS and still determine D? You cannot. Yes or no? So this is full. This is full. So you can notice everything will be full. Like AB determining, this is also full. This is also full. Okay. Similarly, you can notice AC determining D, this is also full. And AC determining E, these are also full. These are also full FDs. Is this clear? So you can notice, you check candidate key determines non-prime attribute. You check this type of FD. You check this type of FD. You check this type of FD. And you check, are they full or no? Are they full or partial? So you can notice all of them are full. All of them are full. So all of them are full. Okay. This type of FD, all are full. This type of FD, all are full. What it means? All are full. So it means 2NF, right? Yes or no? This type of FDs are full FDs. All of them are full FDs. So I can say your answer will be 2NF. So this relation is in 2NF. What about 3NF? The same question. What about 3NF? What can you say about 3NF? Non-prime attribute, can it determine prime attribute? What about 3NF? Tell me. For this question, what about 3NF? What about 3NF? In 3NF, for 3NF, what you will do? For 3NF, what you will do? For 3NF, you need to check, is some non-super key. Is some non-super key determining non-prime attribute, right? is some non-super key determining non-prime attribute. You will have to check this correct. Is some non-super key determining non-prime attribute? This is what you have to check. Agree or not? Yes or no? You have to check that non-super key, some non-super key, is it determining non-prime attribute? Okay, this is what you have to check. Okay, now tell me. So let me take one by one. Like here, non-prime attribute. Let me take, for example, can this D be determined by some non-super key? This D, can it be determined by some non-super key? Can it be determined? Okay, just look at this FD set and tell me. Like, look at this FD set. This FD set is given to you. Okay, C is determining B, and AB is determining CDE. AB is determining CDE. Okay, so look at this and tell me, if you want to determine D, you definitely need AB, right? Agree or not? Agree or not? You definitely need AB. You definitely need AB. Okay, but if someone is determining AB, then that must be a super key. If someone is determining AB, if someone is determining AB, then that must be a super key. Agree? Yes or no? If someone is determining AB, then automatically that is a super key. The same logic you can give for E. Same logic will come for what? Same logic will come for what? Same logic will come for E. Yes or no? Same logic will come for E. This is already a candidate key. This is already a candidate key. And you already know that. This you already know. You already know that if this is a candidate key or this is a super key, every candidate key is a super key, right? If someone can determine this, then what we can say? Then we can say alpha is what? Then alpha is super key, correct? This you already know. Second, also you know that if someone is determining candidate key, then you can say that is a super key. Then that is a super key, correct? Then this beta must be a super key. So these things you already know. So you can notice, if you want to determine D, then there is a guarantee that you need AB. Okay, you need AB. But if someone can determine AB, then that must be a super key. So if anyone can determine AB, then that must be super key. So what I can say, non-super key cannot determine non-prime attribute, right? Yes or no? Non-super key cannot determine non-prime. So this is not exist, correct? This is not exist. If this not exist, then not 3 enough, right? So this is in 3 enough because it does not exist. So this is in 3 enough. So this relation is in 3 enough, right? Okay, so for this question, you can notice which normal form. This is in second normal form also. Okay, so you can notice AB determines CDE and C determines B. Okay, so AB can determine everything. AC can determine everything. What about BC? So this is 3 enough also. This is second normal form also. Okay, this is second normal form also. And so the answer will be third normal form, not BC enough. Actually, answer will be option C. Okay, answer will be option C because option C covers option B, right? The option C covers option B. No, this is a MCQ question. This is a MCQ question. In the ISRO exam, all the questions are MCQ. In the ISRO exam, all the questions are MCQ. The answer will be what? The answer will be option C. Why? Because option C covers option B. If it is 3 enough, then automatically it is BC enough, right? Yes or no? Are option C covers option B? Option C covers option B. Yes or no? Yes or no? Option C covers option B. So the answer will be option B. Answer will be option C. So is this clear? What will be the answer? The answer will be option C. Why? This option C is correct answer. Why? Because option C covers option B, option A. Option C covers A, B. Option C covers 1NF, 2NF. Agree or not? Option C covers 1NF and 2NF. So the answer will be only option C. So if you do option B, that will be wrong. Is this clear? If you do option B, that will be wrong. Because option C covers A, option C covers B. So option C covers option A, B. So that is the reason answer will be option C. Let's see this question. This is your GATE question. GATE 1997 question. A very simple question from the normal forms, from the normalization in DBMS. Okay. So a relation is given to you, a database relation R, A, B, C, D, 4 attributes are given, and the domains are include only atomic values. So automatically what it means? Automatically this means what? Domain include or atomic values. Okay, where the domain include atomic values, only atomic values. So this simply means that it is in one NF, right? Okay, yes or no? This R is in one NF. Correct. This relation is in first normal form because the domain of all the attributes, they include only atomic values. That is the definition of first normal form. Only the following FDs they hold. Okay, only the following FDs hold, and that can be inferred by them. Okay, so these FDs are holding. A determines C, B determines D. These FDs are holding. Okay, so now let's solve this question. So let me tell you one thing. This same question has come, exactly same question. The exactly same question, not even a word change, not even a comma change. Okay, not even a word, not even a comma changed. Okay, the exactly same question has come 4 other times. See, this is one time, this is one time, get 1997, this is one time, get 1997, another time UGC 2013, another time NILIT 2016, another time ISRO 2018, another time UGC 2017. So the same question, like, can you see the obsession with this question? Can you see the obsession with this question? Anyway, so all these people, okay, yeah, they copy. Most of the time they copy the gate questions. So this question is copied 4 times. Okay, this gate question as it is. This question as it is copied 4 times. Okay. And one more thing, actually, this question is also copied from a standard resource. Okay, this question, like I found the standard resource. This is also taken from a standard book. This question is also taken from a standard book. But anyway, so let's see. This is a simple question. So R relation A, B, C, D. These are the attributes, and these are the functional dependencies. A determine B, C determine D. These are the functional dependencies. So you tell me, sorry, A determines C, B determine D. A determines C, B determine D. Okay. A is determining C and B is determining D. So first of all, you find out what are the candidate keys. So can you notice which attribute is not on the RHS of any FD? Which attribute is not on the RHS of these FDs? A, B. So A, B must be part of every candidate key, correct? A, B must be part of every candidate key. Let's see what they can bring. AB can determine AB trivially. This will happen trivially. Okay, and you can notice A can determine C, B can determine D. So you can notice this is the only candidate key. So what are the non-prime attributes? What are the non-prime attributes? What are the non-prime attributes? So definitely AB is the only candidate key. So automatically the non-prime attributes are C, D. These are the non-prime attributes. And you can notice. Okay, now you can clearly see that this exists, right? Okay, let's checking for 2NF. Check 2NF. Check 2NF. What is the method 1? The method 1 is this FD. Look at this FD. Look at this FD. AB determining C. Look at this FD. Is this full or partial? Look at this FD. Is this full or partial? Look at this FD. Is this full or partial? Look at this FD. This FD. Consider this FD. This FD, is this partial or full? This FD is partial or full? Full or partial? So this FD is because you don't need B. Yes or no? Agree? You don't need B because A can determine C, right? See, A can determine C. A can determine C. There is no need of B. You don't need this B. Agree? Okay, A can determine C. A can determine C. A can determine C. A can determine C. So you don't need B. This is not needed. Can you notice? This is not needed. We can remove it. If you remove it, still. So this dependency is partial. This dependency is not full. This is partial dependency. So this AB determining C, can you notice this is a candidate key? This is a candidate key. And this is a non-prime attribute. This is non-prime attribute. Can you notice? Can you notice? This FD exists. Which FD exists? Candidate key determining non-prime attribute. This FD is partial. This FD is a partial FD. So this type of FD, if this type of FD is partial FD, if this type of FD is partial FD, then your relation is what? Not into enough, right? If this type of FD is partial FD, then your relation is not into enough. Because what is happening? What is happening? that candidate key is partially determining non-prime attribute. Correct? Candidate key is partially determining non-prime attribute. So this is what is happening. Candidate key. You have a candidate key. Candidate key is partially determining non-prime attribute. So this is not into enough. This is your method one. Of course, you can apply the method two also. The violation of 2NF. What is the violation of 2NF? Violation of 2NF. What is that? You can apply the method 2. That is violation of 2NF. When violation of 2NF happens? Violation of 2NF happens when proper subset of a candidate key, when proper subset of some candidate key, okay, where proper subset of a candidate key determines non-prime attribute, right? Okay, so when proper subset of candidate key. So here you can notice the proper subset of candidate key you have, for example, A. Okay, that determines non-prime attribute, that is C. So definitely this is the violation of 2NF, right? This is the violation of 2NF. So not 2NF. So not in 2NF. But tell me, okay, this is the misconception. What is the misconception? This is full or partial. This is full or partial. Look at this FD. Look at this FD. This FD is full or partial. Look at this FD and tell me, is this FD full or partial? This is full FD. Remember, this is full FD. This is a misconception. This is a misconception. This is a wrong concept. Many students, they study this wrong concept. Okay. Many students, they study this wrong concept that this is partial. Okay. Remember, this is full. Why this is full? Because the definition of full dependency says that, can you remove something from here and still determine C? Tell me, can you remove something from here and still determine C? Do you fully need A? Tell me, do you fully need A? Do you fully need A? Do you fully need A to determine C? Do you fully need A to determine C? Do you fully need A? Fully need A to determine C? The answer is yes. So this is a full dependency. Is this clear? So this is a full dependency. You cannot remove something from here to determine C. You cannot remove something here. You cannot remove something from here and still determine C. So remember, this is full dependency. This is full FD. This is not partial. Remember, this is not partial. If any student is thinking that this is partial, that is a misconception. That is a wrong concept. Okay, that is a wrong concept. And if you think this is partial, okay, if this concept has been taught to you, okay, if you have this misconception, you should study the normalization playlist of Go classes, or you should study the Navate textbook, or the course textbook, or the course original paper, or you can simply watch the normalization playlist on the Go classes YouTube channel. On the Go classes YouTube channel, the normalization playlist, complete playlist is available. Okay, so on the YouTube you can search normalization Go classes. Okay, normalization Go classes, you can search on the YouTube. You will find the complete playlist. That complete playlist you can watch, or you can study Navate book, or you can study course book. Basically, whatever standard resource, you study some standard resource, because this is a misconception that this is a full dependency, because you fully need A. You fully need A to determine C. Okay, so this is the idea. Anyway, this relation is not into enough, right? This relation is not into enough. So definitely your answer will be option A. If it is not into enough, then automatically it is not in 3NF. Okay. Every violation of 2NF is also violation of 3NF. So this is violation of 3NF also. If you notice, this A determines C. This is violation of 3NF also, right? Why this is violation of 3NF? Tell me, why this is violation of 3NF? Because this is not a super key. Because this is not a super key, and this is non-prime. And this is non-prime. Okay, so this is violation of 3NF also. Let's see this question. Tell me the answer for this one. The question on your screen, a very simple question. So this is a question from the book Korth Database System Concepts, 6th edition, from the book Korth, the 8.3 question. What the question is saying, this is a simple question. Can you try this? So tell me. So tell me, what about this? Explain how functional dependency can be used to indicate the following. Explain how functional dependency can be used to indicate the following. Okay. One-to-one relationship exists between entity set student and instructor. Many-to-one entity relation exists between, okay, student and instructor. Okay, anyway, forget about this. Tell me about this one. Okay, tell me about this one. State comma district. Look at this state and look at this district. Okay. What relationship exists between these two? State comma district. What relationship exists between these two? You have states, and you have districts. So which relationship exists between these two? Many to one, one to one, one to many. Okay, like which? So you can notice between these two, between state and one, can I say many to one exist? Can I say many to one exist? Okay, a simple one by one I'm asking. One by one asking. Can I say many to one exist? Can I say many to one exist? Can I say many to one between state and district? Or can I say one to many? Which exist? One to many between state and district, or one to many between state and district? Tell me. Like, this is my question. My question is very simple. Many to one between state comma district. State comma district. Common sense. Use your common sense. Use your common sense. Use your common sense. Which statement is correct? Tell me. Which statement is correct? Which statement is correct? Many to one between state and district, or one to many between state and district? Sorry, state and district. State and district. Which statement is correct? Use your common sense. Like between state comma district, which exist? Between state comma district, which dependency exists? Tell me. Which dependency exists between state comma district? So definitely between state comma district, one to many exists, right? One to many to one does not exist, correct? So one to many exists between state comma district. And this is a common sense. This is a common sense. You can just read the statement. Just read the statement. Only read the statement. Look at the statement. Read the statement. Which relationship exists between state comma district? Between state comma district. So one to many exists, right? One to many exists between state comma district, correct? Because one state can have many districts. Okay, one state, it can have many districts. So here, if you have a state between state comma district, if you notice between state comma district, what will happen? One state can have many districts, right? Okay, one state can have many districts. Like this can happen. This can happen. But one district will have only one state, right? One district can have only one state. One district can have only one state. Yes or no? Yes or no? Is this clear to everyone? Tell me, is this clear to everyone? So one to many exist between state comma district. One state can have many districts. One state can have many districts. So this is the situation. Okay. Now you tell me. So who can determine whom? Okay. District. If you know the value of district, if you know the value of district, can you tell me the value of state? If you know the value of district, can you tell me the value of state? Of course. Okay, let me tell you the name of district. Let me tell you, like Mumbai, what is the state? Mumbai. If I give you the value of district, Mumbai, what the state? Maharashtra. Automatically Maharashtra. Like Bangalore, state will be Karnataka. Okay, yes or no? So like this. Next, Jaipur, state will be Rajasthan. So you can do like this. Okay, so this, okay, what about state? If I give you the name of state, can you tell me the name of district? Like if I give you the name of Maharashtra, if I give you the name of state, can it determine district? Can you determine district? No, you cannot determine district, right? So a very simple question. This is a very simple question. So you can very easily see that if you have, okay, if you have many to one between, if you have many to one between set A comma set B, if you have many to one between set A comma set B, then what you can say, you have a many to one relationship between set A comma set B. What it means? You have many to one. You have many to one between set A comma set B. You have many to one. You have many to one. You have many to one between set A comma set B. You have many to one between set A comma set B, right? You have many to one between set A comma set B. Many to one, many to one, many to one between set A comma set B. So it means many of A can be related to, yes or no? Is this clear? Many to one between A comma B. It means many of A can be related to one of B. But remember, from B to A, this is one to many. From B to A, from B to A, from B to A, from B to A, this is one to many. Agree? From B to A, this is one to many. From B to A, this is one to many. It cannot happen. From, okay, it cannot happen. Tell me, can it happen? Can it happen? Can it happen? Can it happen? Sorry. What I'm saying? Can it happen? Can it happen? Look at this. Can it happen? Look at this. Can it happen? Can it happen? No, this cannot happen, right? Because remember, from A, if you see, that is many people will be related to one people. From A, if you see, many people will be related to one people, because many to one between A comma B. So from A side, many people will be related to one people. But from B side, one person will be related to many people. But it cannot happen. See, one person will be related to many people. One person will be related to many people. But it cannot happen that, okay, it cannot happen that this type of situation cannot happen, right? Yes or no? This type of situation cannot happen. So this is what I'm saying. So this type of situation cannot happen. Is this clear? Is this clear? So which functional dependency can describe this situation? Which functional dependency can describe this situation? So what can you say about functional dependency? Can I say A will determine B? If you know the value of A, can you determine value of B? If you know the value of A, can you determine value of B? Yes. Okay. And if you know the value of B, you cannot determine A, right? You cannot determine A, correct? If you know the value of B, you cannot determine A, because for the same value, you have many value in the A. Is this clear? Agree or not? Is this question clear to everyone? So for this, answer will be this. Okay. The same question. Let me ask you the same question. If I make it one to many, if I make it one to many between A comma B, now what? One to many between A comma B. So between A comma B, you have one to many. One to many. One to many. Okay. One to many. One to many. So between A comma B, you have one to many. So this is what you have, right? So here in this situation, like one to many between, okay, you can notice one to many between courses comma student. Yes or no? One to many between courses. For example, this can be courses. For example, this can be courses. Yes or no? This can be courses. This can be students. Yes or no? This can be courses. For example, here what can happen? Many to one. Many to one. Many to one. Okay. For example, these can be people. And this can be country. Yes or no? This can be country. Many to one. So there is a many to one between people comma country. Agree or not? There is a many to one between people comma country. So like that. So similarly here you can notice that this, in this situation, what are the functional dependencies? What are the functional dependencies that can describe this situation? So you can notice that, of course, A cannot determine B, right? A cannot determine B, because for the same value you are getting many value. Array, A cannot determine B because for the same value of A you are getting many value of B. But B can determine A. Okay. So this is the idea. Next, if I have many to many, now what will happen? If I have many to many, now what will happen? In this situation, many to many, for example, okay, many to many, like I can say these can be students and these can be games. Correct? Okay, many to many between students comma games. One student can play many games. One game can be played by many students. So this is your many to many situation. This is your A, this is your B. Many to many situation, like one student can play many games, and one game can be played by many students. One game can be played by many students. Okay, one game can be played by many students. So like this is your many to many situation. So definitely you can notice that A cannot determine B and B cannot determine A, right? B cannot determine A. Finally, many one to one. Finally, one to one. One to one. Okay, you have one to one. You have one to one between A comma B. Means if you know the value of A, there will be one value in B. One to one. One to one. If you know the value of B, there will be one value in A. Okay, so here you can notice that if you know the value of A, you can find out the value of B. If you know the value of B, you can find out the value of A. Okay, is this clear? Let me know. So remember one more thing. Now, some of you might be thinking, sir, one to one, does it mean like if this is not related to this? Okay, yes or no? Like, if this is not related to anyone, if this is not related to anyone, okay, let's assume this is also not related to anyone. Now, if I give you the value of X, can you find out the value in B? Now, if I give you the value of X, can you find out the value in B? So, is there any problem here? Is there any problem here? Is there any problem here? So there is no problem here because remember the definition of FD. Remember the definition of FD. There is no problem here because remember the definition of FD. What is that? Remember definition of FD. What is that? Definition of FD says that X determine Y. What it means? It simply means that like if A is here and B is here, then whenever you will repeat this A, this B will automatically repeat. Yes or no? Okay, whenever you will repeat this A, this B will automatically repeat. But remember, if you change the value of A, then this B may or may not repeat. If you change the value of A, this B may or may not repeat. Is this clear? Let me know. So remember, X determines Y. This is the meaning. So you can notice if you have one to one, okay, then you can say that A will determine B because whenever this value will repeat, this value will repeat. Agree or not? And similarly, B determine A because whenever this value will repeat, this value will repeat. Okay, so this is the idea. Okay, like this you can solve the question. So is this question clear to everyone? Like what is the answer for this fourth question? Fourth 8.3 question, what is the answer? One-to-one relationship set exists between entity, student and instructor. So what is going to be the answer? So what are the functional dependency? So there will be functional dependency from student to instructor, and there will be functional dependency from instructor to student, and many to one between student and instructor. Many to one between student and instructor. Okay, now this in this situation I can say that student can determine instructor, right? But instructor cannot determine student. Student can determine instructor, but instructor cannot determine student. Okay, because you have many to one relationship between student and instructor, means many students can have single instructor. Okay, many students, they can have single instructor. One faculty can have many students. Is this clear? Let me know. And the answer is also given. Did you notice? I gave you the answer also. Okay, so this answer is also given in the course. This answer is also given in the course. Is this clear to everyone? So student can determine instructor. Instructor cannot determine student. Is this question crystal clear? Is this question crystal clear? Tell me. Now let's see the next question. So this is a question from the same course book, but this is a 5th edition, I think. Okay, I think this is a question from the 5th edition. This is not a question from the 6th edition. I think this is a question from other edition. Maybe I don't remember the edition, but this is not a question from the 6th edition. Some other edition. This is a question from some other edition. Okay, basically they have changed the account. Basically, yes or no? In the 6th edition they have student comma instructor, and in this edition they have account comma customers. Okay, the only change is this. So here what will happen? One-to-one relationship exists between account comma customer. So I can say account will determine customer, customer will determine account. Okay, yes or no? And this is a very common sense. Agree or not? This is very common sense, right? That Okay, so if you have one-to-one relationship between customer comma account, if you know the customer, you know the account. If you know the account, you know the customer. Similarly, many-to-one relationship between account and customer. What it means? It means one customer can have many accounts. Yes or no? One customer can have many accounts. Okay, but one account must belong to one customer. Okay, so if you know the account, you know the customer. If you know the account, you know the customer. But if you know the customer, you cannot tell the account. Is this clear? Because many to one relationship exist between account and customer. So many account, single customer can have many account. Single customer can have many account. So if you know the account, you can tell the customer. But if you know the customer, you cannot tell the account. Okay. So this is your answer. So you can clearly see account can determine customer. This is your UGC NET 2018 question. Now you can see this question is taken from which resource? Okay. Now you can see this is your UGC NET Computer Science July 2018 question. This is a nice question. This is copied from course, but this is a nice question. Yes or no? This question is taken from course. This question is taken from course, but this is a nice question. Okay. And let me tell you that UGC NET, it asks many nice questions. Let me tell you, like if you see all the exams, then the best questions are asked in the GATE exam. Okay, GATE and TIFR exam. They ask the best questions. Like these two exams, they ask the best questions. Like they ask their questions are the best questions. Okay. And on the second number, I will put this UGC NET. On the second number, I will put this UGC NET exam. Okay. Is this clear? On the second number, you will put the UGC NET exam. And after 3 or 4 numbers, I will skip 3 or 4 numbers, and I will put on the 9,10, I will put the ISRO exam. Okay. And I will put the NET exam questions. Sorry, this NEET exam questions. These are very poor questions. Okay. So I will skip some numbers. Can you notice? Okay. Where I'm skipping these numbers. So here you can put the goclasses and GATEOverflow test series. Okay. So here you can put, actually you should put goclasses GATEOverflow test series here, because some UGC NET questions are not good. Some UGC NET questions are very poor. But anyway, you can put that. Okay. Here, basically more priority you should give to our goclasses GATEOverflow test series and questions. Okay. Test series and questions. Because we take questions from the standard resources. Okay. Because all the questions in our test series, all the questions in our weekly quizzes, all the questions in our that we solve in the lectures. Okay. Basically all the questions that we practice, whether we practice in the lectures or in the weekly quizzes or in the test series or whatever. Okay. In the practice set. So all the questions are from the standard resources. Okay. So all these questions that we take, that these are directly based on standard resources. We take directly from the standard resources. So that is the reason quality. Okay. That is the reason the quality of goclasses and GATEOverflow test series and questions, quizzes. Okay. That is best, because we take questions directly from the standard resources. Okay. From many standard resources, from many standard books. Okay. These questions we take, because you can notice that in the GATE exam, in the other exams, many standard questions they ask directly. Okay. Anyway, let's solve this question. So tell me the answer. So the question is very simple, that many to one relationship exists between R1, R2, between R1, R2, many to one exist. For example, this R1 can be students. Yes or no? For example, this R1 can be students and this can be course. This R1 can be students and this can be course. Okay. Yes or no? So you can notice that many students can enroll in a course. A course can have many students. Okay, in one course you can many students can enroll, and you can do like this. Okay. So here you can clearly see that many to one exist between R1, R2. Between R1, R2, many to one exist. Many to one relationship exists between R1, R2. It means many of R1. Okay. So if you know the value of R1, can you tell the value of R2? If you know the value of R1, can you tell the value of R2? Clearly, yes, right? Okay. So definitely R1 determines R2, but you can notice R2 does not determine R1, right? R2 does not determine R1, correct? Because you can notice, if you know the value of R2, you cannot find out the value of R1. You cannot, because there can be many value in the R1. Okay, there can be many value in the R1. So you can notice that what I can say, that if these are the primary key, if this is the primary key of relation R, then I can say that this primary key will determine this primary key. So the answer will be option A. Okay, so this is a simple question. Is this clear? Let me know. Okay, now let's see the next question. This is also UGC NET question from 2017. UGC NET question from 2017. The same question they are asking, exactly same question. Many to one relationship exists between R1 comma R2. So you have R1, you have R2, okay, and there is many to one relationship that is existing between. Okay, so there is a many to one relationship between R1 comma R2. So many of R1 can be related to R2. Okay, like for example, you can understand that maybe this is a people, maybe these are the people, and maybe these are the country, maybe these are the country. Okay, so you can notice that many people can have same country, and same country can have many people. Okay, but you can notice that, so if you know the person, okay, and this is the primary key, and the question is saying this is the primary key of relation R. So if you know the value of R1, then you also know the value of R2, right? Okay, if you know the value of R1, then you also know the value of R2, correct? Okay, so you can clearly see that the answer will be option B. In this question, the answer will be option B. Is this clear? Let me know. Okay, so quite simple. Let's see this question. Tell me what is the answer. This is NILIT Scientist B 2016 question. So normalization form, which is based on transitive dependency, is classified as this normal form, which is based on transitive dependency. It is classified as, so based on transitive dependency, that is classified as third normal form, three enough. This is a very, like, question wise, this is a poor exam. This NILIT exam, question wise, this is very poor, but the post is very good. Scientist B, the post is very good, the job is very good. Okay, the job is very good. You will get a government job, yes or no? You will get a government job with a good salary. The salary is also very good. I think if you include all the benefits, if you include, then almost 90,000 of salary you are getting per month, and that is a government job. In a government job, 90,000. Okay, and this is a very nice job. This is center job. Okay, job for NIC, National Informatics Center. National Informatics Center. Okay, so I think couple of years ago I got this, actually, this NIC Scientist B. I got this, but I did not join. The joining letter was in my hand, but I did not join this. But anyway, because I wanted to become a teacher, I wanted to go for teaching field. So that is the reason I did not join. But the job is very good. Okay, the job is very good. The reason I did not join, that was something different, because I wanted to become a teacher. Okay, if I did not want to become a teacher, then definitely I would have joined. Okay, so anyway, so you can check out this exam, you can check out. Okay, this exam, this form you should definitely fill. Okay, this NILIT exam, Scientist B and Scientific Technical Assistant A. Okay, so this form you should definitely fill. Okay, you should definitely fill this form. So these are the exams that I have I cracked, like DRDO I cracked this NILIT Scientist B, and also Scientific Technical Assistant A. And there is a BIS, there is a Bureau of Indian Standards. Bureau of Indian Standard. This is a Ministry of Consumer. Okay, in the Ministry of Consumer, like, who gives the ISI, what is that code? IS on the Hallmark code. Yes or no? Hallmark, some Hallmark code is there. Okay, so okay, you can check it out. But an ISI, okay, I think that is ISI code. Okay, so this organization. Okay, so this also you can fill it. You can fill the form of this organization also. So DRDO, NIC, and BIS. Okay, and ONGC. Yes. So these four I got. Now let's see this. So tell me about this one. Actually, if you get under, I can say, if you get top of 150 or maybe 100 rank, if you get top 100 rank in the GATE exam, if you get top 100 rank in the GATE exam, then in the GATE CSE, if you get this rank, then automatically you will get ONGC. Okay, you will get IOCL. You will get this BIS. Sorry, yeah, okay, you will get the BIS. DRDO, there will be another exam. Okay, so this you will automatically get. Okay, and for DRDO, there will be another exam. You have to give exam for DRDO. You have to give exam for NIC. Okay, so they will have their own exam. And bark is here also, here also. Bark is here also, bark is here also. So you have both the choices for bark. Okay, let's move on. So let's see this question. HCU PhD. This is Hyderabad University PhD question. So can you try this? So here, what the question is saying? The question is saying that a relation is given to you, R, A, B, C, D, E, has the following functional dependencies. What are all the keys? When the question is asking for the key, then what the question is asking? When the question is asking for key, what the question is asking? Super key or candidate key? Super key or candidate key? So when, okay, this means key. Key means candidate key. Next, what is that? So you have to find all the keys. So tell me, which attribute does not appear on the RHS? Every attribute appears on the RHS, right? Every attribute is appearing on the RHS. So let's find out what is A plus. What A can determine. Every attribute appears on the RHS. So let's find out A plus. A plus will give you AB. That's it. Nothing else. A plus can give you AB. B plus also cannot give you something. Okay, C plus also cannot give you something. Okay, like so D plus is also not useful. So okay, so anyway, now let's see. Only A can give you AB. Other things are not as useful. So what you should check now? Now you can check. Now you don't have to check AB. Now can you see you don't have to check AB? Yes or no? Can you notice? Can you notice you don't have to check AB because AB cannot give you anything. Okay, AB cannot give you anything. So let's check AC. Let's check AC closer. So the AC closer will give you A will give you AB. C so this will be A will give you AB. So this is ABC. Now BC will give you D. BC will give you D. Now AD will give you E. So everything you got. Now if someone can determine A, that also I should put agree or not. If someone can determine A, that also I should put agree or not. If someone can determine A, so C plus, that also I should put agree or not. If someone can determine A, just think about it, yes or no. If someone can determine A, because AC can determine everything. See, this AC is saying that I can determine everything. This AC is saying I can determine everything. I can determine everything. This AC is saying I can determine everything. What this C will tell you? This C will say, okay, I can determine, agree or not? I can determine you. See, AC is saying I can determine everything. I can determine everything. Now this CE will say I can determine A. So you can notice this C plus, that also will be C, and you can notice C can determine A, and now AC can determine everything. Now AC can determine everything, correct? Now AC can determine everything. So this is also candidate key, yes or no? So we got what candidate keys we got, and now, if someone can determine C, that also must be there. If someone can, for example, maybe I can put AD also. What about AD plus? Because AD can determine E. Because AD can determine E and A can determine B. So if you see the AD plus, what that will be? A can determine AB, AD can determine E, and finally you can notice BE can determine C. So AD is also candidate key. Okay, so what are the candidate keys we can write here? So your candidate keys, if you notice, then you can notice AC is a candidate key, AD is a candidate key, okay, and AB is not a candidate key. So AB is not a candidate key. AC we have checked, AD we have checked. AE, what about AE? What about AE? What about AE? So A can determine B, E, and you can notice B can determine, and AC can determine everything. So that is also there. So A is also there. Okay, so with A, everything we have seen. With A, everything we have seen. Agree or not? So A is done. Okay, so I can say A is done. With A, everything we have seen. And we have also seen that. Now let's check for C. Okay, let's check for C. With C, now forget about A. Now forget about A. Now let's check for C. So C is also there. What about CB? What about CB? So CB can determine BCD, BCD, CD. What about CB? CB, CB. CB can determine BCD, right? Nothing else. Okay, so definitely CD is not there. CB is not there. Definitely CB is not there. And CD is also not there. What about CE? C is it there? Okay, CA, you don't, CA is already, so you don't have to worry about it. So these are, now C is done. Can I say C is done? Okay, now C is done. A is done. Now forget about A, forget about C, forget about A, forget about C. Now let's check the remaining. What about BD? What about BD? BD cannot determine everything. What about BE? BE can determine C, and EC can determine everything, right? So BE can determine everything because BE can determine C, and BC can determine uh, BE can determine C. Okay, so with B you can take B with B. So now B is also done. Now B is also done, and automatically E is also done. So here B done. What is remaining then? What is remaining then? Then the last is DE. What about DE? The last that is remaining, that is DE. Okay, that is not a candidate key, right? So now you can notice. So B is done, and all these. Okay, what about three attribute? What about three attribute prime key? So you can notice that. Okay, can I take some three attribute prime key, like all the things that we did not take? For example, B, D, and C. What about this combination, BDC? This combination cannot determine anything, right? Okay, so you can check it out. I think these are the only candidate keys. You can check it out. You can check it out. I think these are the only candidate keys. Okay, because if you take a three attribute key, see. If you want to check three attributes, if you want to check three attributes, now you can notice that you cannot take A, right? You cannot take A. Why? Because if you take A, now what are the remaining two? Yes or no? What are the remaining two? Because A is already pairing with everyone related other than B. Agree or not? If you want to check three attributes, then you can notice that A cannot be here. A cannot be here because if you put A, then what are the remaining two? If you put remaining two, automatically it will become a non-candidate key because already these are here. These are candidate key. So A you cannot put. Okay, what about C? A you cannot put. A you cannot put. If I put C, E you cannot put. What are the remaining two? If I put C, you cannot put E, you cannot put A. So the remaining two are BD. But you cannot, BCD are already not determining anything. Okay, so this is also gone. This possibility is also gone. This possibility is also gone. So now you cannot put C. Do you agree that now you cannot put C? So you cannot put C, you cannot put A. Now you cannot put C, you cannot put A. These two you cannot put. So the remaining three, which are the remaining three? You cannot put C, you cannot put A. The remaining three you have, okay, these are B, E, D, but B is already a candidate key. But B is already a candidate key, so this is also not a candidate key. Because B is already candidate key, so this is not a candidate key. So these are the only three, these are the only candidate keys. But did you notice one thing? Did you notice one thing that you must be certain that only candidate keys are these. This is very important. This is very important. You must be certain. This word certain, yes or no? You must be certain that there is no other candidate key. Is this clear? You must be certain that there is no other candidate key. So that is the reason I'm checking like this. Okay, like this I'm analyzing. This analysis I have done so that I am certain that there is no other candidate key. Okay, so is there any non-prime attribute? Is there any non-prime attribute? There is no non-prime attribute, right? Okay, there is no non-prime attribute because the candidate keys are these. These are candidate keys. So there is no non-prime attribute. All are prime attribute. So automatically this is in what? If all are prime attribute, then automatically in 3 enough, right? Okay, since all attribute prime attribute, all attributes are prime. If all attributes are prime, it simply means the relation is in 3 enough. Okay, so it simply means that the relation is in 3 enough. And what about BC enough? What about BC enough? This is not a BC enough, right? A determining B. So if you look at A determining B, this is not a super key. This is not a super key. This is not a super key. So this is violation of BC enough. So this is violation of BC enough. So the relation is in 3 enough, but not in BC enough. This is a simple question, but we have done this. Okay, let's see this. Anyway, what is the answer for this question? A relation scheme is in which normal form if it is in 1NF and if all non-prime attributes are fully functionally dependent on the key. Okay, if all non-prime attributes, all the non-prime attributes, they are fully dependent on key. They are fully dependent on key. Then this is in second normal form, right? Yes or no? So that will be in the second normal form. Your answer will be 2NF. Your answer will be 2NF here. Very simple. Let's see this question. This is Stack Overflow question. Question from Stack Overflow. What is the answer here? The question is saying that a relation R, A, B, C, D is given to you and the functional dependencies are given to you. Okay, now the question is saying call this set 1. Okay, basically we are calling this set 1. Let's call this set 1 S1. A different set S2 of functional dependency is equivalent to S1 if exactly the same FDs they hold. Okay, now which of the following is equivalent? So in this type of question, what you have to check? I told you the method. What is the method? Take every option and check, does it cover this, does it cover this? Yes or no? Okay, for every option you have to check, does it cover this, does it cover this? For example, let's focus on this option. Let's focus on this option. See, this is a simple question. If you look at, just do some analysis, right? Before solving the question, do some analysis. Do some analysis before solving the question. Can you notice? In this functional dependency, everyone will determine everyone, like A determining B, B determining C, C determining A, right? Yes or no? A determining B, B determine C, C determine A, and there is no role of D. Yes or no? And there is no role of D, right? There is no role of D. Correct, correct. There is no role of D. Yes or no? So in these FDs, there is no role of D. Of course, what is the candidate key here? In this relation, if I ask you the candidate key, what that will be? In this relation, if I ask you the candidate key, what that will be? In this relation, what are the candidate keys? The candidate keys. Can I say A is the candidate key? Can I say A is the candidate key? No, A is not the candidate key, because who can determine D? Only D can determine D, right? Only D can determine D. So AD will be candidate key, BD will be candidate key, CD will be candidate key. These are the candidate keys. AD, BD, CD. These will be the candidate keys. Is this clear? So anyway, but you can notice this is the idea. This will give you the idea. This will give you the idea that these people can determine each other. These people can determine each other, and there is no role of D. So same thing happens here. Yes or no? Same thing happens here. B can determine A, B can determine A, B can determine C, and C can determine B. So can you notice everyone can determine here A cannot determine C, right? Can you notice A cannot determine C? So here if you notice A cannot determine C, right? Yes or no? A cannot determine C. So this is not equivalent because A cannot determine C. So this option A is not equivalent. What about the next? A cannot determine C, so this is not equivalent. Okay, what about this one? What about this one? What about this one? This you can notice A can determine B, A can determine C. Okay, A can determine B, A can determine C. C can determine A and C can determine B. So now there is a cycle. Now A can determine B, A can determine C, B can determine. Okay, no. B also cannot determine, right? In this, what you can see? You can notice B cannot determine A comma C. Yes or no? B cannot determine A comma C. B cannot determine A comma C. So this is also not equivalent. What about this one? What about this one? A can determine B. A can determine C. Okay, A can determine B, A can determine C. B can determine A, B can determine C. Again, the same thing happens here. What C can determine, right? Yes or no? Again, you can notice C cannot determine A comma C, A comma B. Yes or no? Is this clear? So this is also not correct. What about this last one? C determine B, B determine A, and A determine C. This is correct, right? This is equivalent. Yes or no? This is equivalent to S1 because C can determine B, B can determine A can determine C. So this is equivalent to S1. Is this clear? Is this question clear to everyone? Okay, only fourth is correct. Very simple question. Now let's see the next. These are some questions from the Ullman book. Okay, database systems, the complete book by Ullman, Garcia, Vidom. Okay, second edition. So from the second edition of Ullman book of DBMS, I have taken all these questions, all the exercises questions I have taken, all the normalization exercises questions I have taken. Okay, so let's see this very simple question. Very simple question. So tell me the answer here. Suppose relation R has these attributes. Okay, total you have n attributes. As a function of n, tell how many values, how many super keys are there? How many super keys are there? if the only key is A1. If the only key is A1. Again, what key means? What key means? What key means? That means candidate key, right? That means candidate key. So tell me here. So how many super keys will be there? Any superset of this? Are every superset of this? So just find out number of superset of this. Just find out how many supersets are there. So number of supersets of A1. So what is the number of supersets of A1? For every other attribute, you have two choices. For every other attribute, there are two choices. Correct? For every other attribute, there are two choices. So the answer will be 2 power n minus 1. Okay, what about this? The only keys are A1, A2. The only keys are A1, A2. So you can notice this is the candidate key A1. Okay, and so you can assume that let's assume these are the super keys of A1. These are the super keys containing A1. So what are these? These are super keys containing A1. These are super keys containing A1. Okay, and these are what? These are super keys containing A2. These are super keys containing A2. Correct? So what are these? These are super keys containing both A1, A2. Okay, both A1, A2. So these are super keys containing A1, A2. So your answer will be what? Your answer is very simple. So your total number of super keys. So what will be the total number of super keys? Total number of super keys will be, you can notice, super keys containing A1 plus super keys containing A2 minus super keys containing both A1, A2. Okay, you add this, but when you do this, these you are counting twice, 2 times. Okay, the common things you are counting 2 times. So how many super keys that contain A1? That is 2 power n minus 1. That is 2 power n minus 1 and minus 2 power n minus 2. Okay, so the answer will be, this will be, you can clearly see, this is your answer. 2 power n minus 1 plus 2 power n minus 1. What is that? That is your 2 power n, right? 2 power n minus 1 plus 2 power n minus 1. That is your 2 power n minus 2 power n minus 2. Your answer will be 2 power n minus 2 power n minus 2. Correct? Yes or no? This is twice of this. So that will be 2 power n minus 2 power n minus 2. This will be your answer. So for this question, answer will be, 2 power n minus 2 power n minus 2. Okay. What about the next? The only keys are A1, A2, A3, A4. This is also very simple. Okay. You just find out what are the supersets of, so 2 power n minus 2 plus 2 power n minus 2 minus 2 power n minus 4, right? Correct? Yes or no? So 2 power n minus 2, 2 power n minus 2 plus 2 power n minus 2 minus 2 power n minus 4. For this question, what will be the answer? Because remember, here you have A1, A2 and here you have A3, A4. So that is the reason this is happening. And what about this one? A1, A2, that will be 2 power n minus 2. A1, A3, that will be 2 power n minus 2. But they're common. That is A1, A2, A3. That is A1, A2, A3. So the common will be 2 power n minus 3. The common will be n minus 3. Yes or no? 2 power n minus 3. Is this clear to everyone? Because A1, A2, A1, A3. So the overall, this is A1, A2, A3. Okay. Overall, this is A1, A2, A3. So your answer will be this: 2 power n minus 2 plus 2 power n minus 2 minus 2 power n minus 3. Is this question clear to everyone? Because remember, when you have A1, A2, like here you have A1, A2, and here you have A1, A3. A1, A3. So then common part will have what? So the common part will be called A1, A2, A3. So the common part will be A1, A2, A3. So that is the reason. Okay, this is the reason. Let's see this question. The next question from the same Ullman book of the DBMS. Now, this question, what the question is asking, the FDs are given to you. Okay, what are all the non-trivial FDs that follow from the given FD set? Okay. What are the non-trivial FDs that follow from the given FD set? You should restrict yourself to FDs with a single attribute on the right side. Okay. So you should restrict yourself to the FDs which have single attribute on RHS. So tell me how many total will be there. You should restrict yourself. You should, okay. So now this question is very nice, that on the RHS single attribute must be there. On the RHS single attribute must be there, and you have non-trivial FDs. The question is asking for non-trivial FDs. Is there any ambiguity here? Nikhil, there is no ambiguity in this question, because the RHS must have single attribute. The RHS must have single attribute. Yes or no? The RHS must have single attribute. So this question is a very nice question. There is no ambiguity in this question. Okay, this question, if this question comes in the GATE exam, there will be no ambiguity, because the question is saying that you should consider, you should count only those non-trivial FD where the RHS has single attribute. Okay, on the RHS you have single attribute. So this question, how many non-trivial FD will be there? So one by one you can do that, right? Okay, so what you can do here, so these are your FDs, like AB determines C and C determines D, and you can notice D determines A. So for this question, what you can do? For this question, tell me what you can do. How can you process this? If I ask you number of, this is my first question. This is my first question. If I ask you number of non-trivial FDs, if I ask you number of non-trivial FDs with single attribute on RHS, with a single attribute on RHS. If I ask you this question with a single attribute on RHS. Now, how to solve this question? What is the best method? Yes, one by one you take LHS. Okay, you one by one you take LHS and you count. One by one you take LHS and you count. For example, first you take single. Okay, your case one. What you will do? You create the cases. Is this clear? You create the cases. What the case one? Case one. Single attribute on LHS. Single attribute LHS. Single attribute on LHS. Right? This is your case one, that you have single attribute on LHS. In this situation, A cannot do anything, right? Yes or no? In this situation, A is gone. A is gone because it will not give you non-trivial FD. You want non-trivial FD, so A cannot give you anything. Okay, B cannot give you anything. B cannot give you anything. C can give you D. C can give you D, and C can also give you A. C can give you D, C can give you A. Remember, you have to find the closure. You have to find the closure. Single attribute on LHS, find closure. Yes or no? Find closure. Find closure. So C, you can notice, if you find C plus, if you find C plus, that will be C plus. If you find, that will be CDE. If you find C plus, that will be CDE. So the non-trivial FD will be C determining D, C determining A. So there are two, correct? Yes or no? So I can say there are two. What about D? Yes, D can determine only A. Okay, there is a one. So here finally, in this case one, how many I got? In this case one, how many I got? Total in the case one, total how many? 3 I got. In the case one, 3 I got. Yes or no? CDA. Yes, CDA. Okay, so in the case one, I got 3. What about case 2? What about case 2? In the case 2, 2 attributes on LHS. 2 attributes on LHS. On the LHS, you have 2 attributes. Okay, so for example, AB. If you have AB, find the closure, find the closure, find the closure. So AB can determine, okay, with AB, you check everything. With AB, AB can determine C. AB can determine D also. Okay, so 2 you got with AB. 2 you got with AB. What about AC? With AC, what you are going to get? AC closure, if you find, AC closure, if you find, then you will find that AC closure will give you D. AC closure will give you D. This is AC is done. What about AD? AD closure will not give you anything. AD closure is not going to give you anything. So AD is done. Yes or no? So AD closure, you don't have to worry about. Okay, so 3 we got because of A. Because of A, we got 3. Can I say, okay, because of A, we got 3. Okay, like if you include A, like on the on the LHS, if you put A, then we got 3. Now forget about A. Now forget about A. Forget about A. What about BC? What BC will give you? So BC is going to give you D, comma A, right? BC will give you D, BC will give you A. So 2 you got because of BC. Okay, and you can notice because of BD, forget about A. What, because of BD, what you are going to get? Because of BD, you are going to get A. right? Yes or no? Because of BD. So only these. So finally, because of B, you will get 3. Now B is done. Now B is done. Okay. Now A is done. B is done. What else is remaining? In the 2 attribute on LHS, what else is remaining? Only CD is remaining. What CD can determine? CD can determine A, right? If you find the CD closure, that will give you A. So finally, in the case 2, how many we got? In the case 2, how many we got in the case 2? Okay, 3, 3, 6, and 7. Total 7 we got, right? Yes or no? Is this clear? In the case 2, we got 7. Now, can you find the case 3? In the case 3, how many we will get? So in the case 3, how many we will get? In the case 3. So you can create the case 3. In the case 3, sing 3 attributes, 3 on RHS. Yes or no? 3 attributes on LHS. So if you have 3 attributes on LHS, then what will happen? Okay, so you can check ABC. With ABC, you will get D, right? Okay, with ABC, you will get D. You can check ACD. You can check ACD. So with A, only these are there. With A, only these are there. So ACD. ACD will not give you B, right? Okay, so only this will give you. So ACD, there is no need to check. There is no need to check. Now forget about A. Sorry, okay, one more is remaining. What is that? ABC, ACD, ABD. ABD. ABD will not give you, ABD will give you C, right? Okay. So because of A, if you take A, then only 3 possibilities are there. Either you can take BC, or you can take BD, or you can take CD. Now A is done. Now forget about A. Now forget about A. Only BCD is remaining. Only BCD is remaining, and that can bring A. So in the case 3, how many you got? In the case 3, how many you got? In the case 3, total 3 you got. Okay. And finally, the case 4. The case 4 will not give you any non-trivial FD, right? Okay, case 4, no non-trivial FD. No non-trivial FD, right? No non-trivial FD. If you take all the attributes, then no non-trivial FD you will get. So finally, your answer is what? For the first question, what is your answer? 3 plus 7 plus 3. That is, okay, so that is 13, right? So for the first question, your answer will be 13 FDs. Okay, is this clear? Is this clear to everyone? What about this next question? What are all the keys of R? So what are the keys of R in this question? Like if you have this attribute set, then what are the candidate keys? You can notice B is not on the RHS. So B must be present, right? B must be present. Now AB can determine what? AB can determine everything, right? So AB can determine everything. B must be present. AB can determine everything. So DB is also, DB can, because D can generate A. Because D can generate A. Okay. What about CB? CB, yeah, CB is also there, right? Because CB. So all 3 keys are there. So how many keys are there? Total 3 keys are there. So what is the second question answer? That is 3. 3 candidate keys. Okay, what is the answer for the third? What are all the super keys that are not keys? What are all the super keys that are not keys? Remember your keys are AB, DB, CB. Your keys are AB, DB, CB. Okay, if you see the third question, remember your candidate keys are given like AB, DB, CB. Actually, you can think that every superset of B. So what is super key? What is super key? What is super key? Every proper superset of B, right? Every proper superset of B, correct? Agree or not? Every proper superset of B. So number of super keys, what that will be? So number of super keys, what that will be? Number of super keys. Every proper superset of B. So there will be these many supersets minus 1. These are the supersets. These are the supersets. This is for proper superset. This is for proper supersets. This I am removing for proper superset. This I am removing. Yes or no? What is super key? These are the, your relation is R A B C D. This is your relation. You can see that every superset of B is key. You can see that because these are the candidate keys. Look at the candidate keys. Nikhil, array superset of B is also B. Superset of B is also B. That is not a super key. B is not a super key, right? B is not super key. B is not a super key. So is this clear? So we should remove B. We are removing B here. So these are the super keys. So if the question asks you super keys, the answer will be 7. So if the question is asking super keys, the answer will be 7. And but the question is asking what? Number of super keys which are not keys. So I can say 7 minus 3, 4 super keys which are not key. Which are not a key. Is this clear? Is this crystal clear, this question? Remember, you can notice your relation is ABCD. Your candidate key are AB, DB, CB. So every proper superset of B is a candidate key. Every proper superset of B is a super key. Okay, every proper superset of B is a candidate is a super key. You can do with inclusion exclusion also, but this method is you can notice that this method is basically short. Yes or no? This is a quick method. Simple observation. Simple observation that every proper superset of B is a super key. You can do with inclusion exclusion also, but that will take time. Okay, if you want method 2 for the question number 3, if you want to make method IE method, inclusion exclusion method, if you want to take, then that will be like this: AB, BC, and BD. So what you will do? You will do AB plus BC plus BD. This value with this value is what? This value is going to be what? So this value is going to be like 2 power 2. This is going to be 2 power 2. This is going to be 2 power 2. So 4 plus 4, that is 12. Minus 1 their combination, like minus ABC. You take the combination of this, that will be BCD. That will be BCD. You take the combination of that, that will be ABD. So you take the 1 combination of, okay, you take the combination like this, 2 combination. This value will be, so this value will be minus 3. Sorry, this value will be, here you will have 2, here you will have 2. So this value will be minus 6. Correct? It will be minus 6. And then you will add all of them, like A, B, C, D. That value will be 1. Your answer will be what? The number of super key. The number of super key, that will be what? That will be 7. Number of super key will be 7. And now the question is asking number of super key which are not key. That will be 4. Yes or no? Finally, you can remove these candidate keys you can remove. So you can do that also. So for this question, answer is 4. This is your question 3.1. Is this clear? Let me know. Okay, let's see this question quickly. Read the question carefully. Repeat the same exercise 3.2.1 for these questions. Okay. So can I give this question as a homework? Same question with a different schema. The same previous question. The same previous question with this schema. The same, exactly same question. For every question, what you have to find? What the first thing you have to find? What is the first thing you have to find? Is it non-trivial FD with RHS single attribute? First, you have to find non-trivial FDs, number of non-trivial FDs with a single attribute on RHS. The second you have to find is candidate keys. The third you have to find is number of super keys which are not keys. So 3 things you have to find. Is this clear? For every question, you have to find 3 things. Okay. So this question you can find for each question 3 questions. For each, what you have to do? For each you have to do, you have to find number of non-trivial FDs. Number of non-trivial FDs with RHS single attribute. Okay. The second, you have to find number of candidate keys. The third, you have to find number of super keys which are not candidate keys. Okay, so these three questions you can take as homework for each. Okay, so this you can take as homework and write your answer in the comment. Okay, this video I will upload on the YouTube channel. So today you will find this video you will find on the YouTube channel, on the GoClasses YouTube channel. So if you are watching this video on the GoClasses YouTube channel, you should write your answer in the comment. Okay, write your answer in the comment. Okay, so to all of you also I want to suggest that, okay, solve this question, and maybe like if you don't want to solve all of them, maybe like for example, maybe Yuvraj can do this, Mavit can do this, okay, Nikhil can do this. Okay, so maybe one of them like you can solve completely, one of them you can solve completely, and you can write your answer in the comments. Okay, so for all the three questions I'm expecting that you write for all the three questions. Okay, well, like one person can write for one question, one person can write the answer for one question. Okay, that is your choice. Okay, so this is the question. Okay, let's move on now. Let's see the next. This is the next question. Let's see this. Now the question is saying which of the following are not valid FD rules? So tell me, is this valid FD rule? A determines B, can I say B determine A? Definitely this is not valid. Why? Very easily you can see A, B. You can notice, for example, 1, 1, 2, 3. For example, maybe I can say 1, 2, 1, 1. You can notice A determines B. A determines B, but you can notice B does not determine A. Okay, so A determines B, but B does not determine A. For example, like this you can say. Okay, so A determines B, but B does not determine A. So definitely this is not correct. If AB determines C, A determines C, AB determining C, A determining C, then can I say B determines C? This is also not correct. Okay, you can clearly see. Okay, what is the best method? Tell me, what is the best method? What is the best method? What is the best method? The best method is in this. What is B plus? The best method is in this. What is B plus? In this B plus is B. In this B plus is B. So this is a wrong. Okay, so this is a wrong. This is the best method. This is the best method. Okay, so tell me, in this, what you need to find? Sorry. This. Okay, so in this, what you need to find? In this, what you can say? Can you say A determines C? Can you say A determines C? In this, if you find A plus, that will be A. In this, if you find B plus, that will be B. So we cannot say this or this. We cannot say this or this. Is this clear? We cannot say this or this. Let's move on. Let's see this question. Show that if a relation has no attribute that is functionally determined by all the other attributes, then the relation has no non-trivial FD at all. This is a nice question. Okay, see the question, what the question is saying. The question is saying that if a relation has no attribute that is functionally determined by all other attributes combined, that is functionally determined by all other attributes combined. Okay, just this question, the best method is what? Just tell me, the best method is what? The best method, that is what? Contrapositive. The best method is contrapositive. If you want to solve this question, the best method, that is contrapositive. What is the best approach? The best approach is contrapositive. Contrapositive. So in the contrapositive approach, what you will do? In this contrapositive approach, what are you going to do? In this contrapositive approach, assume there is a non-trivial FD. Okay, assume there is non-trivial FD. Assume there is non-trivial FD. Then what should happen? Okay, then what should happen? Assume there is non-trivial FD. Assume there is non-trivial FD. Then what should happen? Then there should be some attribute which is determined by all others. Then there should be some attribute which is determined by all others. Yes or no? Then there should be some attribute for some A. Agree? Agree? Do you agree? Yes or no? This is the contrapositive approach. This is the best approach. Contrapositive. You know contrapositive. If P implies Q, Then what is the contrapositive? What is the contrapositive? The contrapositive negation Q implies negation P. Okay, so this is the contrapositive. So you can very easily see that for this question I am saying that the best approach is a contrapositive approach. So if you assume there is a non-trivial FD, just assume there is a non-trivial FD, then definitely this will happen that some attribute for some A, some attribute, then definitely this will happen. For some A, the remaining attributes will determine A. Now, this is very easy to prove. Why? Assume there is a non-trivial FD. If you are assuming there is a non-trivial FD, then you can I assume this type of FD where something is determining something, some attribute? Because see, you already know that if you have something like alpha beta determining AB, what you can write it? Like if you have alpha determining AB, this you can write it what? This you can write it alpha determining A, alpha determining B. Okay, so like this you can notice. This you can write like this you can write like this. Correct? Okay, so this you can write like this you can write like this. So this is if and only if. So you can just assume that non-trivial FD, you can just assume that non-trivial FD has single attribute on the RHS. Can I assume this? Can I assume that your non-trivial FD has single attribute on the RHS? Because you can do this. Because if you have more than one attribute on the RHS, then what you can do? If you have more than one attribute on the RHS, what you can do? You can split the RHS. You can split the RHS. If you have alpha determining AB, then you can write it alpha determining A, alpha determining B. So you can split the RHS. So I can assume there is a single attribute. Okay, whatever attribute you want. For example, let's assume your relation is this. Let's assume your relation is like this: A, B, C, D, E, F. This is your relation. Whatever attribute, tell me which attribute should I take? Tell me any attribute. Okay, for example, let me take C. Okay, let me take C. Now, because this is non-trivial FD, so can C be here? Because this is non-trivial FD, so can C be here? C cannot be here, right? Okay, so someone is determining this. Maybe let's assume B is determining this, or let's assume BF is determining this. Now, what is the problem? If this happens, then automatically what will happen? Then automatically you can notice that R minus C will determine C. Agree or not? Then automatically R minus C will determine C. Yes or no? Is this clear? So if you have non-trivial FD like this, then automatically what will happen? That R minus C means I can say A, B, D, E, F. They will determine C. That's it. This is your proof. Hence proved. Hence proved. Yes or no? Hence proved. Hence proved for some A. Hence proved. Isn't it simple? So very nice question, right? Nikhil is asking how to develop this type of intuition. When you read the question, you can think like this. Like this question is very easy. Like when you read the question, automatically it will come to your mind. This contradiction, like prove by contrapositive, contradiction. Okay, so like these will come to your mind automatically. This is an easy question. This is not a complicated question. Okay, this is a easy question. This is not a complicated question. Let's move on. Let's see this question. Tell me the answer. Okay, last. Okay, let's take this last. So X and Y are set of attributes. If X is subset of Y, then, so this is what we have to prove. Yeah, this is what we have to prove, that if X is subset of Y, then X closure will be subset of Y closure. This is very easy to prove, right? Because if X is subset of Y, see, if like for example, if X is subset of Y, remember X is subset of Y. Now you can notice that if X can determine, if X plus is alpha, means X can determine alpha, right? It means X can determine alpha. So if X plus is alpha, means X can determine alpha. Then what I can say? If X can determine alpha, Y is superset of X, right? Y is a superset of X. This Y is superset of X. So definitely this Y has something extra. So definitely this Y also can determine. Okay, if this X itself can determine, it's like this. Y is basically alpha X. Okay, maybe y is basically it's like this. My y is zx. Y is zx. So you can clearly see what is y plus. Y plus will be zx plus. Zx plus will be whatever zx plus. It will contain everything that x can determine. It will contain everything that x can determine. So you can notice y plus is a definite something extra can be there. So definitely you can notice that y plus is a superset of x plus. So this is an easy question. Okay, this is a easy question. So if x is subset of y, then definitely x plus will be subset of y plus. So this is an easy question because very simple that if this subset, if this can determine something, if this can determine something, if you can determine something with this, then definitely this bigger thing, what this bigger thing will determine, this bigger circle, what this will determine, this will determine something more. So you can notice if this small circle can determine this, then definitely this bigger circle, you can notice this will determine something bigger. This will determine something bigger. Okay, so like that. Anyway, so this is enough for today, and actually some more good questions are there. For example, in the next session we will solve this question. We will solve, this is a very nice question. Actually, this is my favorite question. Okay, this is my favorite question. Actually, this is a very nice question if you have done this. Yes or no? Have you tried this question? This is a very nice question, like excellent question. Okay, definitely, like this question is something that should come in the GATE exam. This type of question should come in the GATE exam. So anyway, in the next session we will solve this question also, and we will solve these two questions also. So these are the questions, and also, yeah, okay, we will solve this question also. So these are the, okay, so some questions are remaining, so those we will see in the next class. Okay, in the next session we will see. Okay, BCN of decomposition, 3N of decomposition, all these we will do tomorrow. Okay, tomorrow we will do, because basically tomorrow what we are going to do, tomorrow our DBMS, we will do 3N of decomposition, BCN of decomposition. This algorithm we will see. Okay, how to do 3N of decomposition, BCN of decomposition. The few more things about some like few more things about redundancy. We will study what, like some notes, redundancy notes, some few notes about redundancy. Okay, few notes about redundancy. Okay, and these questions. Okay, and these homework one pending questions. Today I will give you homework two. Okay, I will give you homework two today, and some, yeah, NPTEL questions. Okay, NPTEL questions. So this is our for purpose, and tomorrow we will start at, okay, actually, okay, we will definitely start at 8 p.m. 8 a.m. Okay, so definitely, like definitely we will start at 8 a.m. Okay, definitely I will start at 8 a.m. Okay, so these things, because we need to do all these things tomorrow. Okay, so I think it will take a lot of time, but okay, these things we will do tomorrow. So today I will give you homework too. Okay, this homework too I will give you based on queries. This I will give based on queries. Okay, okay, thank you everyone. Okay, so at 8 p.m. 8 a.m. we will start. Okay, okay, so okay, so thank you everyone. Anyone has any doubt in this? Okay, so this video I will upload on the YouTube. Please like the video and share the video. Okay, and put your comment. Okay, see, like, see, whenever you see some video on GoClasses YouTube channel, whenever you see some video, just put some comment. Okay, like whatever comment, like you can put some emoji. Okay, so if you don't like, just put some comment. Whenever you find any video on GoClasses YouTube channel, okay, press the like button. See, it will not take time. These things will not take time. Okay, these things will not take any amount of time. Whenever you see any video, whenever you watch any video on the GoClasses YouTube channel, whenever some video of GoClasses YouTube channel comes in front of you, just press the like button. Okay, and put comment, like randomly put some comment. Okay, maybe anything you can comment, like awesome, 100, you know, there is a emoji 100, some emoji. Okay, no, anything, like, okay, if you have, like, if you want to, if you want to put some comment related to the video, if you want to write the feedback, okay, like what did you feel about the video, so that you can do, of course. But if you are not, like, if you are not putting that comment, then put something. Okay, so do that. Okay, please do that, because you know, Go Classes YouTube channel, okay, that is not reaching to the many students. So still many students are you know, still many students, many students, they are learning the same wrong concepts, they are learning the same misconception, same wrong concepts, same rote learning, okay, no proof. Basically many students, they are still thinking that what they are learning is the perfect. Like still many students are thinking that their teacher is a god, okay. So the teacher is telling, their teacher is teaching in a very rote learning manner, okay. Everything the teacher is giving, just okay, remember, by heart, by heart this table, by heart this formula, by heart this result, by heart this, by heart that. But still many students, they don't realize, okay, like the quality of Go Classes. So please help us to reach more people. Whenever you see any video, whenever any video of Go Classes comes in front of you, just press the like button and write some comment, okay. Like whatever emoji you can put, like just put any comment, whatever you want, okay. Just put some comment, some emoji you can put, some good you can put, nice you can put, awesome you can put, some word you can put, or you can put your feedback about the video, okay. Like what did you like, okay. You can put your like genuine feedback, okay. Maybe because that feedback will help us. We read every comment, okay. We read every comment. So whenever you say that, okay, in this video I found this good, this good, okay, this video taught me this. So whenever you write some comment, then we read that comment, and that tells us, okay, what was good in that video, okay. So and if some doubt is there, you can write that doubt also, okay. Okay, thank you everyone, see you tomorrow, okay. Can we start at 6? Okay, so tomorrow we will start at 6 a.m. 6 a.m. we will start tomorrow, 6 a.m. Okay, I will announce it right now, okay. Immediately I will announce, okay. Thank you, bye.